Today we're going to be learning all about trees and how amazing they are, just like this old tree that I have climbed up and I'm standing in right now. Mature trees like this one can store about 48 pounds of carbon a year. So trees, as we know, they breathe in carbon and they exhale oxygen. So they're sort of like the lungs of the earth. So it's really important that they can absorb that carbon and store it. It helps us to regulate our climate. And scientists actually advocate for planting more trees to help reduce the impact of climate change, which is a really cool thing that we can even do in our backyards. But we know that trees also exhale oxygen, and a tree like this one can produce enough oxygen for about 4 people in one day, which is pretty cool. That's a pretty direct benefit to us. We also love trees to look at. They're beautiful. They provide shade. They reduce our cooling bills in the summer if you have a nice tall tree next to your house or building. They also provide a wonderful habitat for animals and other wildlife. Another really amazing thing about trees that scientists are just learning about is they can communicate with each other. And scientists now know that they can send nutrients and communicate with each other through this underground network called the mycorrhizae, and soil fungus produce this network. It's sort of like an internet, but underground. And this is a whole new field of study. I always find it amazing because we think we've got nature all figured out. It's been here since, the beginning of time, and we know everything there is to know, but there's new things we're learning all of the time, which is really amazing. And one of the questions I get a lot in the fall, especially from students and teachers, is why do these leaves change color in the fall? It's really cool, right? When we see that leaves turn color. And it's always a shame because by the time the fall hits, a lot of the exploring that would help us answer that question is already done. In order to answer that question, we have to start looking at trees now in the spring and the summer when the leaves are still green and learn a little bit more about how that process works. So our essential question for today is, how do leaves help trees? Leaves are an adaptation of trees. It's something that is very critical to their survival. We're going to explore that today. Hi everyone. So I set my camera up so you could see my workspace here. Since we're studying leaves today, I went into my backyard and I gathered different types of leaves that I could find. Most of my backyard has maple leaves in there, but a way that you can actually identify your leaves, which is a really cool trick I learned, is if it's a maple tree, you can count out the divots in the leaf. So if you look at this leaf, there's a little divot right there. And if I were to, say, put my leaf here, and I'll draw it for you here. The first divot, I'm going to put an M. Second divot, I put an A, then a P, then an L, and then this one is an E. On this little spring leaf, you kind of have to pull it apart to see all the divots, but that spells maple. If I had a oak tree here, they're sort of shaped differently and they've got sort of 3 divots and they're longer, so it spells O-A-K, which is another way to remember it. Now, I thought I would use a Sharpie marker for the purposes of this so you could see my drawing show up a bit more. Usually I will use a pencil so I can erase. But there's many ways that people use their journals. I like to just sort of set a timer and free draw what I see and then go from there. Others do a technique where, I'm going to try this, they just take their pen and they never lift it off the paper. And they just make one continuous line and they focus not so much on what they're drawing, but what they're seeing. Right? And they just sort of let their pen guide them. They have that deep divot. There you go. And then I'll go back in and fill in the detail from there. So I like to sort of give just myself like set a 2-minute timer and make as many observations as I can see. and then take a break, take a step back, and then maybe set it for another 2 minutes. And I always find so much more every time I go back. It's amazing the level of detail that you can find just from one leaf. And I'm really fascinated by this system of veins that I see coming up. I can see it almost looks like a tree within the leaf, sort of branching around the leaf. When I flip over the leaf, I notice that these veins are much more apparent. So I'm going to write darker on the flip side. So because I cannot really draw that very well, I have found that I can just make that label there. So I remember that the flip side of that was darker than the first side. Then I might go and I might draw some of the other things that I found here. This is these little pods that you are familiar with from maple trees. See those during different times of the year. I noticed that my leaves are sometimes really small and sometimes big, depending on what tree that they've come from. And I also noticed that this one is a very different color. This is from a red maple leaf. So beautiful, and they just get bigger and bigger as the season goes on. Some people, especially for our younger students out there, would even maybe draw the leaf, or trace the leaf, I'm sorry. And that's fine to do too. If that is what helps you to really pay attention to the details, that is totally fine too. When I'm done with all of this, I almost don't want to let my leaf go. I kind of want to maybe press it in my journal so I can remember it for later. And that's fine too. Scientists will use something called a leaf press. And see, there you go, little maple leaf. They use a leaf press where you'll just kind of find the middle of your journal, put that there, and I might write red maple leaf, and then I might even put the date. So today is May 7th, 2020, and I found it in my backyard. And I can just put that there, close my journal, and then maybe put some heavy books on top, and after some time the leaf will actually dry out and become stiff, and it's a good thing that I can go back and study later too. So that's my leaf nature journal. So to learn more about leaves, I found this really cool activity where we can pull apart the different colors in a leaf and really dig behind what's going on inside. We're going to use a technique called chromatography, and scientists use this all of the time. They use absorbents to literally pull apart a mixture of colors so we can see what colors lie beneath. So I have a few items I should tell you for this experiment. If you are going to do this at home, I would definitely have a grown-up with you because we are using boiling hot water right here. That's really hot. I don't know if you can see the steam coming off of it. So hot water, coffee filters, which are super absorbent. I'm also going to try some paper towels as well. I have isopropyl alcohol, my leaves, of course, a bowl, and some glass cups. Now, I have done this before with plastic Tupperware, and I have to say it doesn't work as well, so I would definitely use glass, which is another reason you should have a grown-up with you. So remember we said that leaves have chlorophyll in them, and chlorophyll is the compound that helps the leaf to absorb sunlight. And when sunlight is absorbed by the tree or the plant, the plant and the tree is able to turn that into carbohydrates and sugar to help nourish the tree and help them to grow. So we know that most trees that we see, a lot of trees that we see, are like this guy here. They've got green leaves in the spring and summer, and then in the fall, those leaves turn color and they start to fade into a new color, and eventually they fall off. But we've never really asked the question. We always ask, why do they change color? But we've never really quite asked the question, what color is this going to change? Is this going to be a green, or is it going to, is it going to be a yellow or an orange or a red? And in theory, we could kind of predict this. I'm going to have to spend some time here today doing some investigation, and then I'm going to have to watch the trees outside to see if my prediction is true. So go outside, grab some leaves, and make your own prediction. Do you think your green leaves are going to turn yellow, or are they going to turn orange or red? Okay. So to find this out, what I need to do is pull out the color. Now there's a couple of different types of chlorophyll. There's not just one type of chlorophyll. There's chlorophyll A, there's chlorophyll B, and some of the most predominant chlorophyll is this blue-green, and it reflects sunlight. And so that's why we see this green here. So first what I'm going to do, see what I can pull out. These are bright green. I am going to put them in a cup here, and then to kind of get everything sort of moving and all the molecules moving a little bit, we're going to first put hot water. That is boiling hot water. Kind of feels good because it's cold out today. A little bit of a facial. And then I'm going to use this solvent here, which is the alcohol. Okay. There. And just going to let it sit. I'm going to do the same thing with my red maple leaves. And I also have a tropical plant from my house plant. And we'll do that repeat that with each of these leaves. So first, the maple. Again, be careful because we're working with glass here. Okay. And then we've got, again, in your science journals, write down what you think will happen to each one of these leaves. The green maple leaf, the red maple leaf, and the tropical houseplant maple leaf. We filled a bowl with steaming hot water, and then each cup had a leaf and rubbing alcohol and a coffee filter. The idea behind this is that over time, the color is going to be absorbed by that coffee filter and move up, and you'll be able to see the gradient of different colors within that leaf. Okay, I have left all of these chlorophyll filled bowls overnight, and let's see what we found out. So remember my first bowl, what I did is I just put the leaves in, I didn't crush them up, and I filled them with warm water on the outside and alcohol-filled cups on the inside. And the second one, I crushed the leaves up a lot more. Okay, so let's see what we can find. So the first one here, whoops. The first one is this one. And this actually looks like it was the red maple tree, which is this tree right back here. So you can see how brilliant. And if you look at my coffee filter, I see a little bit of red and a very little bit of a green line there, but not a lot of color at all. But what I do see, check this out. This is so cool. The leaf is really brittle, but it's also, I know this was the red one because the stem is still purple. It's totally green, totally green. So we pulled out in that, in this cup, we pulled out all of that red color, and it looks like this deep kind of olive green color. What you're seeing in here is just a mixture of chlorophyll and rubbing alcohol. It smells very strong, like rubbing alcohol. So that's what that is. That's the chlorophyll that we've pulled out of that leaf. Pretty cool, huh? Okay. And then this one was our little baby green maple leaf. And I look at the leaf and it's really brittle and it's a lot lighter green than it was before. And then on my coffee filter, I see that really cool little line of green, just pale green. And then in my cup, look how bright that chlorophyll is. Does it look different from this cup here? Yes, it does. Okay, so this next bowl, this is the one where I crushed up the leaves. So in theory, I was a little nervous that we were not going to get any results, and so I decided to try crushing up the leaves too, because I heard that that can help kind of release everything in the leaf. Okay, so my first one, oh, you know what? In my first experiment, I also forgot I had a houseplant here. So I have a houseplant, which is a tropical plant. It doesn't lose its leaves unless I forget to water it for a long time. And you know what's interesting? Check that out. No color. No color at all on the leaf. And in here, look at that, just a very tiny little speck of green. And the leaf itself looks the same, but it just, you can see where like there's one spot where the chlorophyll's been removed. I wonder if I sit longer, if maybe we would get a little bit more out of it. Okay, so moving on to round two. First, we're gonna start with, oh, I see my purple stem here. This was my purple maple leaf. Wow, so much more dramatic. Remember, this is a paper towel, not a coffee filter, because we ran out of coffee filters. And look at that. That was the leaf that was crushed up first. Look at all of that green, and you can see how what happened was the paper towel, which is really absorbent, when the chlorophyll leaches out of the leaf, it just gets absorbed by the paper towel. And this is a really cool way that scientists can study and pull apart colors to see how, what different colors you see in an object like this. It's just kind of pulling apart a chemical mixture, which is really cool. And then let's look at the leaf. Well, it looks like there's no rubbing alcohol left in the bottom of here. I think the paper towel is the trick. They're much more absorbent than coffee filters. That's another experiment, huh? And there is like no color whatsoever in whatever's left in that leaf. Cool. Okay. So next one is our baby maple leaf. And again, this one was crushed up first. I definitely see, you can probably see that much better on camera now. See that line of green? So what happened was the chlorophyll leached out and it just got soaked up by the coffee filter so you could see it. And look at that bright green color. I just want to show you comparison. This is the crushed up leaf to the non-crushed up leaf. So it's definitely brighter. So if you're going to run this experiment, I definitely recommend crushing up your leaves first. Okay. And then this is the house plant, right? Wow, the house plant, we definitely, that was a thicker leaf, and I have to say, very dramatic results, right? So now we've got a lot of chlorophyll there. So that leaf, which is not a North American leaf, it's a tropical plant, so it doesn't lose its leaves like our trees here do. And so it may have just taken a little bit more crushing and breaking down in advance for it to give up that chlorophyll. So really cool. So what have we learned? We've learned, number one, we can pull chlorophyll out of a leaf. Another thing that we see is that we've learned is that leaves have different colors inside of them, and so the primary color is green, and that's what you see in the summer when everything is bright and beautiful. You see that those blue and green colors reflecting with the sunlight and the chlorophyll. And then what happens in the fall is as the chlorophyll begins to leave the leaves, there's not as much sunlight, the leaves begin to prepare for winter and for falling off. The chlorophyll moves into the trunks of the trees and we lose that green color, and that's just that chlorophyll disappearing from the leaf and going back into the tree and preparing for winter. So in theory, if I were to look at my full leaf here, I should be able to predict what color this leaf will turn in the fall if I take all of the color out of it. And this is sort of this lime green kind of color. So my prediction is that in the fall, if we were to continue to pull out the green, the predominant green color in this leaf, that we might see a yellow leaf. The thing is, I don't know the answer to it right now because it's summer. And so I'm going to have to wait. I'm going to have to go follow this tree and see what happens in the fall, see if my prediction is correct. So to learn a little bit more about trees, I have a really cool book that shows us some pictures of what trees look like throughout the seasons. This book actually belongs to one of our educators at Riverbend. So hi Kate and hi Willa. We borrowed your book for this week's lesson. I hope you like it. And let's go through and see what we can find. The book is written by Britta Teckentrup, illustrated by Britta Teckentrup. It looks like it's written and illustrated by Britta Teckentrup. In the forest, all is still, gripped by winter's chill. Owl sits watching his tree. No one sees as much as he. Snow is melting all around, shoots are peeping through the ground. In the trees, young bear cubs play. Spring cannot be far away. Blossoms fall and leaves are growing. A gentle springtime breeze is blowing. Squirrels scamper here and there. Playful fox cubs sniff the air. Birds flit through the leafy bowers. The forest is abloom with flowers. Birds are singing, foxes play. Summertime is on its way. Now summer's here. The sun is high. Bees are humming in the sky. Juicy apples, ripe and sweet, almost ready for you to eat. On a warm midsummer's night, all the stars are shining bright. The trees sway gently to and fro, shimmering in the moonlight glow. Now it's cooler all around. Apples tumble to the ground. Grass is damp with morning dew. Clouds drift across the skies of blue. Autumn leaves turn red and gold. Days are warm and nights are cold. Food is gathered and stored away, ready for a winter's day. The cold north wind begins to blow. Animals shiver, it starts to snow. Time to shelter, find a bed, prepare for winter months ahead. The forest floor is snowy white. In his tree, owl sits tight. Deep midwinter's here more. Wise owl has seen it more. It's silent now, no sounds are heard, not a fox cub, not a bird. The trees are still, the snow lies deep, all the forest has gone to sleep. The seasons have all come and gone, snow has fallen, sun has shone. Owl sees the new spring buds appear. Owl sees the first new buds appear, and so begins another year. So we just did one experiment about leaves, and we learned about chlorophyll that is inside that leaf, and that helps the leaf to feed the tree. So that chlorophyll is attracting the sunlight, and it's helping the tree turn sunlight into really important sugars and carbohydrates for the tree to survive. There are endless different ways that we can look at leaves in trees. Another really cool activity that we like to do, remember when I did my nature science journal? Let's see if I can pull up a leaf here. And I noticed all of those veins in the leaf. Let's see if I can come around here so you can see more closely. See all those veins? And you can kind of see how when I pulled out that red color, you can see those more closely. Another cool thing you can do is if you get a cup, you don't need to heat up the water this time. Just get a cup with maybe some water and some red food coloring. And you can stick your leaf inside and you can actually watch as the stem, this really cool stem, will pull that water up, that red colored water, and you can see it distribute through the leaf and it turns, those veins all turn red. So that shows us that leaves are really important for water transport, or the veins in the leaf are helping transport water around and nutrients around the leaf. So that's another really cool experiment. I can send you a link to how to do that at home. But trees are endless. There's so many different things. We could probably spend a whole week on trees. Now that you've learned so much about trees, I'm sure you're wondering, what can I do to help trees? We know that they're so important to our environment. They help to produce oxygen for people. They help to uptake carbon and store carbon. They look beautiful. They provide shade. They provide homes for wildlife. But trees are certainly in trouble. We lose trees when we destroy habitat, to build things like homes and development and things that are really essential, but that also loses trees. Trees are also important to watersheds because they help to protect our rivers and streams. And so we want to plant trees where we can. You can actually plant trees in your own backyard. You can help with a tree planting. One of the things with tree plantings is it's really important to have a plan to help to take care of those trees for at least 3 years or so. So it's not enough to plant. You also have to make sure that you can make sure that tree is protected, make sure nothing is eating it, it doesn't get sick or ill or destroyed in a frost, especially we just had this crazy spring frost. And another thing that you can do to help trees is look out for this alien invader called the spotted lanternfly. Spotted lanternfly came on the scene a few years ago, and it is spreading rapidly across southeastern Pennsylvania, as well as other areas of the country. Now that we're hitting spring, we're seeing these tiny little nymph stages. There's several stages of the spotted lanternfly. By the time we hit to the fall, they look like these adult flies that have these, they're actually very beautiful gray spotted wings, red abdomen. But right now what you're seeing is these teeny tiny little black nymphs with white polka dots on them. Now, normally I tell you, don't kill bugs. They're great for the environment. Don't kill anything when you go out to nature. But if you do see these, we're going to put a picture up behind me. If you do see these little guys, it would be really great for trees if you just squish them. So that's two things you can really do to help trees. I hope that you had a great time today with this experiment. If you have more questions about trees, send them to me. Send them to education@riverbend.eec.org, and we can do some more tree investigation.